Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and this is part 3 of drawing the graph of the sine function. Okay, I want to just quickly remind you that in the previous 2 videos I talked about the graph of a sine function. We started with the basic sine function, which here's one cycle of that function. We then talked about if we have a coefficient other than 1, we call that a, how does that affect the graph of the sine function? And basically it's a vertical transformation. It either stretches it or shrinks it or flips it over the x-axis. So go back and take a look at part 1 if you haven't done so already. Then in part 2, we talked about how b affected the shape or the graph of a sine function. And basically it stretched or shrunk the graph horizontally. Then we used those values to find amplitude, which is the absolute value of a, to find the period, which is defined as 2 pi divided by b. And then I showed you a technique where I asked you to find increments to help you find your key values, those 5 key points. In this video, we're going to talk about what c does. C is another horizontal transformation, and it actually shifts the graph. So let's take a look at how that happens. So when you have a value of c, then your graph shifts either left or right, and that's called displacement. If you're looking at an electronic application, it might be called phase shift. And the way that you calculate what that displacement is, it's defined as negative c over b. It kind of is opposite of what you would expect. If c is positive, it actually shifts the graph to the left. If c is negative, it shifts it to the right. It's opposite of what you might think intuitively. But let's take a look at this with some examples. If we took a look at an example, and I'm going to keep b1 and a1 just to keep it simplified, I can find all of these values like I normally do. So amplitude in this case is the absolute value of 1. Period is 2 pi divided by b is 1, so period is 2 pi. So the increments for this graph will be the period, which is 2 pi divided by 4. So the increments will be pi over 2. So the distance between those key points will be pi over 2 units along your x-axis. Then, because we have displacement, we calculate that. It will be negative c. So c in this case is negative pi over 2 divided by b, and we've determined that b is 1. So the displacement will be equal to negative pi over 2, which will be positive pi over 2. So that means that the graph is actually shifted pi over 2 units to the right. So if we were to draw this, instead of my first point starting at the origin, at 0, we're going to start the sine curve at pi over 2. So it got shifted over to the right. My increments are pi over 2, so there's my first key point. My next key point would be pi over 2 plus my increment of pi over 2, so that would be pi. My next key point would be pi plus the increment value of pi over 2, so that would give me 3 pi over 2. I add pi over 2 again to get 2 pi. So there's 4 points, I need 5. I add pi over 2 one more time, so 2 pi plus pi over 2 will be 5 pi over 2. So with those key points, I know my amplitude is just 1. So that's my maximum y value and my minimum y value of the graph. I start my function here. I'm going to get zeros at those 3 key points, and the graph will look like this. So it's the same as y equals the sine of x, except it got shifted over pi over 2 units. Let's take a look at some more examples. Okay, in the next example, we have y equals the sine of, in brackets, 2x plus pi, end of bracket. So a in this case is 1. Therefore, I know the amplitude is 1. B is 2. Therefore, I know the period of this function is 2 pi divided by 2, which would be pi units. Therefore, the increments will be pi over 4, because you always divide the period by 4. And the displacement will be negative c, so negative pi, over b over 2. Those are going to be significant characteristics about my graph that will be very helpful in drawing the graph. Again, I'm just drawing one cycle of the graph, remembering or understanding that the graph continues to the right and continues to the left. But we'll just draw the one cycle. The displacement is negative pi over 2, so that means the graph shifted over pi over 2 units to the left. We're going to start our graph at negative pi over 2. And our increments are pi over 4, so that means each of those key values where it either crosses the x-axis or reaches a maximum or a minimum point is pi over 4 units from here. So if I go negative pi over 2 plus pi over 4, we need a common denominator, so that's going to be negative 2 pi over 4 plus pi over 4, and that's going to be equal to negative pi over 4. So this next value will be negative pi over 4. Then if I add pi over 4 again, I get to 0. Then I add pi over 4 again. Remember, we need 5 points. So I go one more. We add pi over 4 plus pi over 4 will be 2 pi over 4, which is pi over 2. And you can always check, because this distance along the x-axis should be equal to the period, which is pi units. So if we took the distance between those, we should get pi, which we do. Now we draw our sine function. Starting here, our zeros are there, and our a value is 1. So the maximum value is 1, the minimum value is negative 1, and now we just draw our sine function. One cycle. There are other ways to draw these, and a lot of other resources will show you different methods. I'm showing you the method that I found students understood the easiest. Let's take a look at one last example. Now, as these functions get more complicated, like it does here where we have a is not equal to 1, b is not equal to 1, c isn't equal to 0, so we have other values, a number of values to consider. We could, just make a note of that, and that might help us find these values. So a in this case is 3, b is pi, and c is negative 2 pi. So just keep those values in mind when you calculate these things. Using these values for a, b, and c, let's calculate these 4 things. Amplitude, absolute value of a, so absolute value of 3. Period is 2 pi over b, so 2 pi over pi, which is 2. Increments will be the period divided by 4, so 2 divided by 4, which will be 1/2. And displacement is negative c, so negative 2 pi, over b, which is pi, so that will be positive 2. Let's draw the graph. So start with the displacement. How far on the x-axis did we shift this graph over? We shifted it over 2 units to the right because it's positive there. So we're going to start our sine function, our sine graph, at that point. Now we need the 4 other key points. So I find those using my increment. So the next one will be, if this is at 2, it starts here. The next point will be 2 plus 1/2, which would be 5/2. Then plus 1/2 gives me 3. Then plus 1/2 again will give me 7/2. Plus 1/2 again will give me 4. So there's my 5 key points. There's zeros at these points. And then I reach a maximum value of A, which is 3, and my minimum value of -3. So my graph will look like this. So again, it's just the sine function, condensed. In this case, it's shrunk horizontally, and it's shifted horizontally, and it's stretched vertically. So it's got 3 different transformations happening. But if you do it in this manner, you don't have to get overly concerned when you see something like this. So I'm going to, next video, take a look at the cosine function. It's very, very similar to what we're doing with the sine function. So when you're comfortable and confident with the sine graphs, take a look at the next video. Take care and see you then.